People start to lose confidence in their ability to move around safely, and they start to limit their activities, they withdraw socially, and it becomes a vicious cycle, because the less active they are, then the more their physical abilities deteriorate, and often ends up with someone unable to live independently because of this fear of falling. We understand the role that foot sensitivity plays in controlling balance. It's more than just an academic exercise. It has real practical implications for people.
We go to the Center for Studies on Aging at Sunnybrook Health Science Center in Toronto. Dr. Brian Mackey's research into foot sensitivity and balance may soon lead to new products to enhance the quality of life for seniors.
The Center for Studies on Aging is located here at Sunnybrook Health Science Center and is part of the University of Toronto. The main goal of our research group is to apply technology and engineering methods to try to solve some of the major problems associated with aging, and falling is one of the major problems. What we're looking at is normal age-related changes in pressure sensation. And this is quite distinct from disease-related changes. For example, in diabetes, we know that this affects your peripheral nerves, which will also affect your ability to sense pressure. But what we're talking about is actually changes in the cells in the feet that sense the pressure itself, or also changes in the skin. The skin becomes stiff and less elastic, then that'll affect your ability to sense the pressure as well.
So, Mr. Wasserman, we're going to be putting these reflective balls on you so that we can determine the joint kinematics, the movement of your joints while you're up on the platform.
The way that we measure the balancing reactions, we stand a subject on a moving platform and we control this platform to move. It's very carefully controlled to move in different directions, so we disturb their balance and then we measure their reactions. The balancing reactions that we're most interested in are stepping reactions, because this, I think, is ultimately what determines whether or not you fall.
Okay, Mr. Wasserman, the motor is going to come on. I want you to relax and try to stand as still as possible. The trial is about to begin. Okay, great.
In order to analyze the motion of the subject, we place these reflective balls on the body and the limbs. The motion of the body is recorded by 4 video cameras that are located overhead above the platform. And all of this is recorded on videotape. After the experiment, we use a computer to process the data. The computer measures from the video data where the balls are and then calculates in 3-dimensional space the movement of the balls. The data that we get from these images allows us to quantify very precisely how stable the subject is. And we measure the motion of the center of mass of the body and we relate that to the motion of the feet. And this is really what determines whether or not you fall. We have some equipment in the other part of our lab where we measure the sensitivity of the sole of the feet. And the way we do this is we have a machine that causes this indenter to vibrate accurately, very small amounts at certain frequencies. And we ask the subject to tell us when they can detect this vibration on the sole of their feet as we change the amount that it vibrates. So we can very accurately determine how sensitive their feet are.
And we'll get you to place your foot over top of the indenter. Yeah. So what we're going to do is vibrate the indenter, which is underneath your foot, and it's going to lightly press into your foot. And I want you to tell me when you detect that.
All right. This information tells us how bad the subject is in terms of their ability to sense pressure. There's a lot of data out there already, so we know how sensitive normal young adults are, and we can look at the effects of aging in comparison to that data. And then ultimately we'll take that data and see how it correlates with ability to balance. So we hope to see, or we predict that we will see correlations between impaired sensitivity and poor performance in balancing.
Thank you.
Thank you very much for attending our balance study here at Sunnybrook.
Okay.
Thank you.
Down the road, we think that this type of research is leading to some very real products that will help people. For example, we could have special footwear with special insoles, textured or with raised edges around the edge of the foot, for example, that may give extra stimulation to the foot and help to compensate for loss of sensation. And we could have a similar sort of surface on the floor as well. Bathroom tiles, for example, could have a textured surface that may give extra stimulation to the foot. The Center for Studies in Aging has developed a number of other products. Most of these are also related to preventing falls and improving mobility. For example, we've developed a special pole system that helps people get in and out of chairs or on and off toilets. We've developed a special patient lift system, a winch if you like, that can be used to help caregivers get people in and out of beds and transport them, for example, from the bed to the bathroom. We've developed a new powered wheelchair. This is a really ultra-maneuverable device that could be used inside the home. Most of the existing powered wheelchairs are simply too big or cumbersome to use inside the home. We've also developed a new wheelchair called the Staxi, and this is a low-cost wheelchair that can be stacked sort of like a shopping cart. So the idea is we could use these in hospitals or in places like airports or shopping malls, wherever older people might need a wheelchair to get around. The overall philosophy of the Center for Studies in Aging is to try to apply engineering methods and technology to try to solve some of the problems associated with aging. So this will have real practical implications. It will allow people to move about more safely and hopefully increase their confidence, so they're not going to develop a fear of falling, they're not going to fall, and they can live independently in their home for a longer period of time, hopefully.